For number 23, we're trying to map the pre-image to the image. In order to do that, we need to see that if I were to rotate triangle ABC counterclockwise 90 degrees, if I were to draw this out, and this will just be a rough sketch, where this was A, B, and C. If I rotate this 90 degrees, I'll have a figure that looks like this, which is very close to looking like this triangle here, but I would then need to reflect over the y-axis, and from there I would need to translate. So I can always rotate my paper to see what my rotations are going to look like. So this was my original. I rotate 90 degrees counterclockwise. So if I do 90-degree counterclockwise, then my rule for that is x, y. 90 degrees, find the opposite of y, switch the x and the y. And if you didn't remember the rule, you could actually plot this out, because this is at -2, 1, and you could rotate it and find that you'll be at -1, -2. So I can apply this rule to, if I know where A, B, and C are, I can figure out where A prime, B prime, and C prime will be after I perform this rotation. So A is at -3, 4. B is at -3, 1. And C is at -9, 1. So our X is just going to become the second number. So this will be -3. My Y will go first, but I'll take the opposite sign. So again, my Y goes first, take the opposite sign. My X stays exactly how it was. And for this one, my Y, I'll take the opposite sign. My X will stay exactly as it was. So now I've got -4, -3. And this is my A prime. B prime will be at -1, -3. So this is B prime. And C prime will be at -1, -9. So to figure out what the line of reflection is going to be, you can, to find the line of reflection, what you're going to do is you need to know that the line of reflection is a perpendicular bisector to each original and prime, which means it will cut the distance between B and B prime in half, the distance between C and C prime in half, and A and A prime in half. So the distance from B to B prime is 1, 2, 3, 4, 5, 6. So my line of reflection must exist at the 3, 1, 2, 3. Same thing for C and C prime. It has a distance of 1, 2, 3, 4, 5, 6. So halfway is 3. So this is my line right here. Now, I'm going to be reflecting over the line. And I need to know if this is a y equals something or x equals something. Those 2 points that I plotted, I can use. This point right here is 2, -3. And this point here is 2, -9. Do we see that both of my x's are 2? So if we plot 2 points on that line, whatever matches up, since my x's are the same, then x equals that number. So I can do 90-degree counterclockwise rotation and then reflect over the line y equals 2. You could have also reflected over the line y equals x and then translated. The line y equals x looks like this. And the rule is xy becomes yx. So all that would happen is once you write down your coordinates for A, B, and C, then A prime would be 4, -3, B prime would be 1, -3, and C prime would be 1, -9. And then we would get this image here, and then we could translate it to the right in order to get this to map perfectly on there. So there were a couple ways to do this one, but as long as you got it to map up perfectly, you are good to go.